All right, so we want to solve the systems of equations. We have two equations here, right? Don't be careful with the fractions. Okay, we have 1 over 2x plus 1 over 3y equals 7 over 6. And the second equation is 1 over 4x minus 3 over 2y equals 9 over 4. Okay, now with the fractions, we can deal with the fractions, do the algebra, add, subtract them, right? But probably is going to be better just to eliminate the fractions, right? To eliminate fractions, we need to multiply each term by the LCD, right? So for the first equation here, we see that they each there's a 2, there's a 3, there's a 6. So the LCD is 6 in this case, right? So let's take the first equation, okay, and multiply each term by the LCD, which is 6, okay? Now, once again, we can multiply by 6 over 1, right, just to make it a little bit more clear here, okay? So we'll multiply each term by the 6 over 1. You notice in this case, on the numerator, we get 6 times 1 is 6, 1 times 2 is 2, 6 over 2 is 3, right? So we get 3x. Here we get 6 over 3, which is 2, so that's 2y. Here, we get 42 over 6, or we can see that the 6 is just canceled out, so we get a 7 in that case. All right, so the first equation here becomes 3x plus 2y equals 7. And for the second equation, the LCD is 4. So we'll take each term, okay, and we'll multiply each term by 4. Or once again, we can do that as 4 over 1. Okay, so we'll multiply the first term by 4 over 1, 4 over 1 on the second term, and 4 over 1 on the third term. Okay. Notice what happens here, right? 4 over 4 is just 1, or just x, right? 4 times 3 is 12, so 12 on the numerator. 1 times 2 is 2. 12 over 2 is 6y. And here, the 4 just cancel out. Or we could do the 4 times 9, so 36 over 4, which is 9, right? So we get that. So these are our two equations, okay? We can rewrite them, I guess, so just so that we can see one related to the other. Now remember, we can solve by either elimination or substitution. And we see that there is a coefficient of 1 here, right? This x term has a coefficient of 1. So in this case, probably substitution may a little bit better, right? So let's isolate this x term. We'll add the 6y to both sides. So we get x is equal to 6y plus 9, right? That is our expression for x. And what we need to do then in the substitution step is to substitute that into the other equation, right, for that x. So we use this equation to get x by itself, and then we're going to substitute that expression for x into the other equation. Let's do that, right? 3 times x, but instead of putting x, I'm going to put 6y plus 9 plus 2y equals 7. And you notice here we only have y's now, so we should be able to solve this for y, right? So 18y plus 27 plus 2y is equal to 7. 18 plus 2 is 20. And you notice from here, okay, I can subtract the 27 to both sides. Right? The 27's cancel out here. So 20y is equal to negative 20. And when I divide everything by 20, I get a pretty good answer here, right? Y is equal to negative 1. That is my value for y. Now, once again, to get x, I can just plug this y value in here. That's probably the easiest, right? That's actually one advantage of substitution. And once you use substitution, once you find one value, that variable, we can just plug that into the expression that we solved, right? So x is equal to 6 times negative 1 plus 9. Negative 6 plus 9 gives us 3, so x is 3. Right? Now remember, as a final answer, though, we should put this as an ordered pair, right? So our final answer should be 3, comma, negative 1.